We have covered one-step equations and two-step equations, but today it's time to step up our equation solving expertise and solve equations with variables on both sides of the equation. Now, I'm super excited for this because I feel like a detective when I'm solving equations. I feel like I'm kind of playing a game and trying to solve a mystery. It's like I'm trying to figure out what x has to hide from me. What value are you x? What are you trying to get away with? Now, with solving equations for today, we are going to use the acronym DCIC. Feel free to call it DSIC, Dkick. I'm going to call it Dkick a lot, or just DCIC. I do not care. Whatever it takes for you to remember this and commit it to memory. In this acronym, D stands for distribute, C stands for combine like terms on the same side of the equation, I stands for using inverses to solve, and the final C stands for checking your answer. Now, this is an incredibly helpful acronym when solving complex equations, but it is by no means the only possible way to solve equations. Just like you don't actually always have to go in PEMDAS or GEMDAS order when simplifying expressions. Now, I need you to keep that on the down low. Be quiet about that because it is a math secret. You don't always need to use order of operations in that exact order when solving. Now, you don't always similarly have to do Dkick in any order. Just like PEMDAS, it's not the only way to get the correct answer, but just like PEMDAS, it will always lead you to the right answer every single time. Now, as you continue to practice and experiment with equations, you will learn some new skills and tricks and figure out when Dkick makes sense and when you can go out of order a bit and still arrive at the proper solution. Now, we're going to apply the rules of DCIC or Dkick to this first example. Now, when I look at complex equations like this, I look at each side of the equation as two separate expressions that need to be simplified before going across the equal sign. That is why I, which stands for inverse, is the last thing I do actually before I check my answer. So we are going to start with D, which is distribution. I see that on the right side of my equation there are parentheses. This will often, but not always, signal that I need to use a distributive property. When I distribute the 2, I am left with 2x plus 20 on the right side of my equation. The left side of the equation remains the same as there is no distribution on that left side. Since there is no more distribution that can be done, I finish the first step of Dkick. We are now going to look at C, which stands for combining like terms. Remember, we are looking at each side of the equation separately. So I'm only combining like terms on the same side of an equation. For example, on the left side, I can combine 5x and 3x to get 8x because they are like terms. I am not going to combine with the 2x because the 2x is over here on the opposite side on the right side of the equation. So we are not going across the equal sign at all until we have fully simplified both sides of our equation. Now on the left side, we still have the constant of 2. So we are left with 8x plus 2 on the left side and 2x plus 20 on the right side. Now both sides of my equation are fully simplified. So each of the sides can be looked at as like a separate expression, and you want to simplify them down, they're now simplified. So I have distributed and combined like terms in order to accomplish this. So now I can move on to using inverses to solve. At this step, I first want to think about getting variables on only one side of my equation. Currently, there is an 8x on the left, and there's also a 2x on the right. We don't want that. We got to fix that situation. So I'm going to pick a variable side. In this case, I'm going to choose to move all my variables to the left, but it really does not matter what side you pick. So I could also choose to move my variables to the right if I wanted to, but in this case, I'm going to pick the left. Please do not get too overwhelmed with that. After you practice, you'll have a little bit more clarity on which side it makes a little bit more sense to pick, but it really does not matter. But since I've decided in this case to move all my variables to the left, I need to get rid of the 2x from the right side of the equation. Since the 2x is positive, I'm going to get rid of it by subtracting 2x from both sides, just like I did when I went over the one-step or two-step equation videos. Once I subtract 2x from both sides, because remember I need to do the exact same thing to both sides of the equation when solving, I end up with 6x plus 2 on the left side and just 20 on the right side. That was an incredibly important step because I now only have variables on one side, on my left side of the equation. Also now my equation, it looks like a basic two-step equation, which we've already worked on, so I'm getting progressively closer to figuring out the correct value for x, because my detective work has been on point so far. Now I need to work to isolate x, so I'm going to subtract 2 from both sides of the equation to undo the addition of 2. This leaves me at 6x equals 18. And I'm now down to my final step, and I need to divide out the coefficient of 6 because it is currently getting multiplied to x. Once I do this to both sides, I am left with x equals 3 for my solution. I had to use inverses to solve, but now I am done with I. My final step is to check my answer by evaluating at x equals 3. When I substitute 3 in for x, I am left with this equation. And in order for the answer to be right, both sides of the equation need to simplify to the same value. Remember to use order of operations when we are evaluating to make sure our answer is correct. But as you can see here, I am left with 26 equals 26, which is a true equation. Therefore, we know our solution of x equals 3 is correct. Now, let's take a look at another equation. Do not let the fraction freak you out. It doesn't change the process of Dkick or DCIC. And this fraction is actually going to be easy to deal with as we work through. First, I'm going to start with distribution. Although there is no distribution that needs to be done on the left side of the equation, I am able to distribute the 1/2 on the right side. Now, distributing a 1/2 is actually pretty simple because it is the same as taking half of each term inside the parentheses. And taking half is the same as dividing by 2. So distributing the fraction wasn't bad after all, because when we distribute the 1/2, we actually got rid of all fractions within the problem. And I know that's a positive for a lot of us, including myself. Fractions can be difficult to deal with. Now, we are going to bring our left side of the equation down as we did not touch it yet, so it's just going to remain the same. I'm now done with distribution, so I'm going to move on to combining like terms. On the left side of my equation, I can combine 10x and the negative 3x to make 7x plus 12. The right side of the equation is just going to remain the same since it is always already simplified and we cannot do any combination of like terms there. We are left with 7x plus 12 equals 9x plus 4. Now I need to move on to I, which deals with using inverses to solve. And this time, instead of making my variable side the left side, I'm actually going to choose to put my variables on the right side. Once again, it doesn't matter which side you pick, so do not take forever making that decision. If I'm going to make the right side my variable side, I need to get rid of the 7x by subtracting 7x from both sides. This leaves me with 12 equals 2x plus 4. Now, I've done enough work at this point that my equation is in a basic two-step equation form. I'm going to eliminate the 4 by subtracting 4 from both sides. Then I'm going to get rid of the coefficient of 2 by dividing both sides of the equation by 2. And this leaves me with a solution of x equals 4 and allows me to move on to the final step, which deals with checking that my answer is indeed correct. When I substitute 4 in for x in all 3 locations, because remember it needs to go in anywhere there's an x, and then evaluate using order of operations, I am left with the left side of my equation equaling 40. And I am also left with the right side of my equation equaling 40. I don't know what just came out of my mouth there. So indeed, the correct answer is x equals 4. Now I'm going to move a little quicker through this third example, so stick with me. Feel free to pause, rewind, and do what you need to set yourself up for success. I would also encourage, if you're not already doing this, to take notes so you can revisit this at a later time. Also, writing things down causes you to remember it more often, so consider that when you're watching the video. Now in this example there's a ton of distribution. In fact, there are 3 areas of distribution in this problem, so I'm going to handle all 3 of those first. Distributing the 4 leaves me with 4x plus 16. Distributing the 3 leaves me with 6x minus 24, and distributing the 6 leaves me with 6x plus 12. Now, since the distribution is done, I'm going to move on to combining like terms. The 4x and 6x combine to make 10x, while the constants of 16 and negative 24 combine to make negative 8. There are no like terms on the right side of the equation, so I'm simply going to bring that down. And now I am set up with moving on to I, which deals with using inverses to solve. I'm going to make my variable side this time back to my left side, just because I want to. So I need to get rid of the 6x from the right side by subtracting it from both sides of my equation. This results in 4x minus 8 equaling 12. Now I can add 8 to both sides of my equation, and then divide by 4 to get a solution of x equals 5. Told you I was going to move through a little bit quicker with that one. Now, I'm going to show commitment to quality by checking that my answer is correct. And I see that by evaluating at x equals 5, I end up with 42 equals 42, which is a true equation. Therefore, x equals 5 is indeed the solution to this linear equation. Now, I want to be clear before I wrap up this video that there are situations where you don't have to do each step of DCIC because a step may be missing. For instance, in this equation, there is no distribution, and you cannot combine like terms. So you would immediately move down to I, the third step, and use inverses to solve. Just think of this similar to when you're using PEMDAS or GEMDAS in order of operations, and say there's no parentheses or exponents, so you just skip down to multiplication and division. Now this example shows that we need to start at combining like terms, so we can skip the distribution and start at C, the first C of combining like terms. There's no parentheses, so I don't need to do any distribution. So just keep that in mind, not every step is always present. Now if a step isn't present, you simply skip it, move to the next step, but there should never be a situation when you're solving a linear equation and you skip the final step of checking your answer. Always check your answer. Now that wraps up this video on solving equations with variables on both sides. In the next and final video for week 2, I'm going to look at additional equations with variables on both sides. But these equations aren't going to necessarily always have just one solution. We're going to look at equations with infinite solutions or no solutions and how to identify those, in addition to similar ones like we had today. Now keep working hard and reach out for support as needed.